Today we're going to look at two more measures of spread. The first is called the variance, and the variance is the average of the squared differences from the mean. Doesn't that make perfect sense? When we go through the process of how to find it, I'll explain what exactly we're doing at each step. And one of the symbols that we use for variance, this is sigma squared. It's actually lowercase sigma. If you remember from sequences and series, we had the uppercase sigma for the summation notation. Now we use the lowercase sigma for both variance and standard deviation. The one we're really going to focus on, though, is standard deviation. This is the square root of the variance, so it's just sigma. And the standard deviation, like I said, it's a measure of spread. It tells you how different each of the data values is from the mean. So if you can imagine, when we're talking about difference from the mean, if you have an outlier, it makes the standard deviation really large. If you have data values that are really close together, close to the mean, the standard deviation will be really small. Next, we're going to look at an alternate method to determine the outlier, and it's based on the standard deviation. So if you have any data values that are more than 3 standard deviations from the mean, that would be considered an outlier, and we'll actually look at that for our last example. In our first example, we're going to be finding the standard deviation by hand. It is a little bit cumbersome. There is also a way to do it on your graphing calculator, which I'll show you next, and we can go over that in class when you have a graphing calculator in your hand as well. So, first you start by calculating the mean. So for this class of 7th graders, the average height is 49 inches. Next, in this little chart here, I've got all of the data values. Notice a couple of the data values repeat, but I didn't put them in the chart twice. So I'm going to make myself a little note when I do this that I'm going to have to multiply that value by 2 because I have 2 data values of 45 and I have 2 data values of 52. So I'm going to multiply that one by 2 as well. So the next step is to find the difference from each data value and the mean. So that's what I'm going to do in my second row. So the difference, and you take, it really doesn't matter which order because the next step we're going to square it. So I'm going to do 49 minus 45. I'm going to keep them all positive, because once I square it, they're going to become positive anyway. So I'm going to quickly fill in this chart. All right, and then in the third row, I'm going to square each of those differences. So this is the variance. It's the average of the squared differences from the mean. And then finally, I'm going to average them all up. So when I add these in my calculator, I'm going to add the value of 16 twice, or multiply by 2 because I had 2 data values of 45. And then same thing with this data value of 9. I'm going to add that in twice. So when I average all of those squared differences, I get 8.4. So that's our variance. We don't typically use the variance, so we're going to take the square root of that and give our standard deviation of 2.9. 2.9 is a fairly small standard deviation. The units would be inches because that is the units of the height or the data values. So what that means is that typically each data value is about 3 inches from the mean. And when you actually look at the data values, it doesn't look like they're all 3 inches from the mean. That's because the data values that are further from the mean, once you square that difference, it affects the variance and the standard deviation much more than the ones that are closer to the mean. So thinking about adding up those 16s 3 times, we had 3 9s that we were adding up, 2 4s, and only 1 1. So those values that were further from the mean made the standard deviation larger than the ones that were closer to the mean. Next, we're going to look at how to use a graphing calculator to calculate the standard deviation. So for those of you who do not physically have a graphing calculator in front of you, you still want to pay attention to this because I will get one in front of you tomorrow, and then you'll have at least seen the buttons and we can play around with it. So here's where we go to use our calculator to calculate the standard deviation for us. There's a stat button right here under the delete button, and we want to edit. First of all, we want to enter the list of data, so that's the editing part, and then you can just hit enter. And we only have one variable data. We've only got one number. Each student, we're just looking at their height. So all of those values are going to go in list 1. So I'm going to type those in real quickly. So we're using the same list of data for the standard deviation we just calculated by hand, and we're going to use the graphing calculator now to calculate it for us. So once we have the data In list 1, we're going to hit the stat button again, and this time we want to calculate. So I'm going to go over to calculate. There's two different types of calculations, one variable and two variable. We're going to look at those later, the two variable. Right now we only have one, so I'm going to hit enter. If you don't type in which list you want, it automatically assumes it's going to be using list 1. Since that's where we entered our data, I'm just going to hit enter again. The first one, X bar, remember X bar symbolizes the mean. We got a mean of 49, that's what we calculated, so we did our mean correctly. This right here, sigma, see that sigma notation? That's for the standard deviation. We got a standard deviation of 2.9 because I rounded to the nearest tenth, which is exactly what our calculator got for us as well. This one right here tells us we had 10 data values, which we did, and if we scroll down on the screen, it shows us a few more pieces of information. Our minimum value is 45, quartile 1 is 46, so it gives you your 5-number summary as well for creating those box plots, median, quartile 3, and maximum value. So those are all the one variable statistics that our calculator will give us. For those of you with a calculator, I also have that data in your notes, kind of the steps that you can go through to calculate the standard deviation like we just did. Finally, we're going to take a look at using the standard deviation to determine if there are any outliers in the data set. So I entered the data into my list in my calculator, and as you're looking through the data, it's all very similar. There's one data value of 92.1 that might be an outlier, but it's still really close to the other data values as far as being off by 0.6 millimeters. So we'll see what happens when we edit our data and calculate that standard deviation. Again, one variable stat, so I'm going to use list 1, which is the given list, or the default list. All right, so looking at our data, we have a mean of 92.8, and we had a standard deviation of about 0.2. So in order to check to see if we have any outliers, to check for a low outlier, we would take the mean and subtract 3 times the standard deviation. Now 92.8 minus 0.6 is 92.2. So any data values smaller than 92.2 would be an outlier. So in this case, that 92.1 that we noticed was a bit different is an outlier. None of the other data values are that much bigger than the mean. The only one that's bigger than the mean is bigger by 0.1. So there's nothing that's 3 standard deviations higher than the mean, so we have no high outliers. I decided not to do a U-try problem for this lesson. I thought it might be a little bit challenging, and the standard deviation by hand is so time consuming. So we can take a look at working on some of the assignment together in class as a warm-up instead.